Welcome to the C++ 17 Features Overview. This presentation provides an introduction to the new features and enhancements introduced in the C++ 17 standard. Get ready to explore the modern C++ programming landscape. C++ 17 introduces several major additions that improve the way we write code. Here's a brief look at some of the key features. This includes structured bindings, compile time if, also known as if constexpr, inline variables, fold expressions, standard optional, standard variant, and standard any. On the right, you can see a glimpse of how C++ 17 simplifies code. For example, structured bindings allow you to unpack values easily. The compile time if lets you write code that is conditionally compiled based on template parameters. Let's delve into structured bindings. Structured bindings allow you to unpack multiple values from tuples, arrays, and structs into separate variables in a single declaration. It simplifies code by eliminating the need for standard tie or accessing individual elements by index. Here's a before and after example. Before C++ 17, you'd have to use standard tuple and standard tie to extract values. With C++ 17, you can directly unpack the tuple into variables, making the code cleaner and more readable. Let's explore compile time conditional statements. The if constexpr feature allows for compile time conditional code selection. Unlike regular if statements, branches that are not taken are discarded during compilation, not just skipped at runtime. This simplifies template metaprogramming and eliminates the need for complex finding techniques. The example shows how you can use if constexpr to choose different code paths based on whether a template type is integral or floating point, all at compile time. Let's discuss header-only constants and variables. C++ 17 introduces inline variables, which allow you to define variables in header files without violating the one definition rule, also known as ODR. This simplifies the creation of header-only libraries and eliminates the need for static class members or external variables with separate definitions. The example demonstrates how inline variables can be used to define math constants directly in a header file, avoiding the need for a separate source file. Now let's take a look at simplified variadic templates. Fold expressions provide a concise syntax for applying binary operators to parameter packs in variadic templates. This eliminates the need for recursive template instantiations when working with parameter packs. It supports all binary operators in 4 different folding patterns, which are unary left or right and binary left or right folds. The example shows how to sum a variadic list of arguments using a fold expression, which is much simpler than the traditional recursive approach. Now let's talk about representing optional values. Standard optional is a template class that can either contain a value or be empty. It provides a safer alternative to using nullable pointers or special values, like -1, to represent the absence of a value. It is useful for functions that may or may not return a value, avoiding exceptions for expected failure cases. The example demonstrates how to use standard optional to represent a function that might not find a username for a given ID. Now let's consider a type-safe union. Standard variant is a type-safe alternative to unions that can hold values of different types. Unlike unions, variants know which type they currently contain and prevent invalid access. It is useful for representing values that could be one of several distinct types without using inheritance or dynamic allocation. The example shows how to use standard variant to create a variable that can hold an integer, a double, or a string, with safe access using standard visit and standard holds alternative. Let's explore type-erased value containers. Standard any can store a single value of any type that satisfies copy constructible requirements. Unlike standard variant, it doesn't need to know all possible types at compile time. It provides type safety through runtime type checking when retrieving values. It is useful for interfaces that need to handle arbitrary types or for implementing scripting like functionality. The example demonstrates how to use standard any to store values of different types, with safe access using type ID and standard any cast. C++17 includes several other notable additions, enhancing its capabilities. This includes the file system library, also known as standard file system, parallel algorithms, standard string view, structured binding for maps, template argument deduction for classes, constexpr statements, nested namespaces, and has include preprocessor expression. C++17 represents a significant step forward in making C++ more modern, expressive, and safer to use. Features like structured bindings, if constexpr, and the new standard library components reduce boilerplate code and make common patterns more concise. Many features that previously required complex template metaprogramming are now part of the core language. C++17 provides a solid foundation for modern C++ development and paves the way for future standards. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.